Hey everyone, sorry for not uploading a video in a long time. There's been so much going on. First of all, we've been having some very long and incredibly productive live sessions going on with this channel, and I've just started doing that because everything that's coming our way is very fast and pretty furious. So by the time I shoot a video, produce the video, upload the video, the new things are coming forth, and I don't mean to be so sporadic in saying this, but if you've been part of the live sessions, then you can understand the information that we've had coming forward and that we've discussed and we've had to analyze on the fly, and then we've had to have discussion with people that just come in with copy-paste arguments. What's a copy-paste argument? That, well, no. Comets are made of ice, and that's a copy-paste argument at this point, because the photographic proof, the scientific proof, all indicates 100% that a comet is a phenomenon of dust and rock. There is no water ice on the surface of, or within at least the first 20 centimeters of a comet. Why? We've been to 7 comets, an incredible project that the European Union Space Agency embarked on was the Rosetta satellite comet chaser, and they chased a comet, an active flying comet that had a perihelion event with the sun, a comet, honest to God, everyday comet. And again, everybody was surprised by what the initial pictures showed. There is no surface ice, but of course it had to be there. It was probably covered in dust. And the one thing that was really cool about the Rosetta probe is that it had a lander called Phileas, or Philly. Phileas or Philly. Do your own research on that and check my just read up on it. It's a fascinating adventure what they did and how they approached a comet, and that they were able to orbit the comet and then send the lander down to the surface of the comet. That totally went disastrous because they were prepared for one surface, which was an icy surface, and what they encountered was a dusty, rocky surface with a very, very weak gravity force. They expected more gravity from this comet. So when the lander came, it was supposed to impale itself into the comet, into that icy surface, and it had little claws at the end of its 3-probe lander, and what actually happened is it bounced off of a very weak and dusty and rocky surface. There was nothing to impale itself on. So now we know that the next lander is going to have to approach it very, very, very slowly and softly touch down on a comet, because it has weak gravitational force, and this lander is going to have to make itself part of that gravitational force, and not an opposite action and reaction where you're bringing this probe in really fast to have the probes and the lander claws inject themselves into the land and wedge themselves in there, because it's Newtonian laws, weak gravitational force, a strong kinetic energy, and so opposite and equal reaction. So here comes this very fast thing into something that doesn't have enough gravity to attract it, and then it's just going to bounce off, because for every action there's opposite and equal reaction. This energy just doesn't stop. This energy, if it hits something that has the ability to push it back, which this surface does, well, it does, and science happens. So, but it didn't fly away. There was enough gravitational force, and it was coming in relatively. I wasn't saying at a high speed, but it was coming in at a speed that it caused a bounce, and it shouldn't have. It should come into the surface of Comet 67P. You can look it up, Comet 67P, and the Rosetta project, and that's the currents that we had. And the probe bounced off and was able to take some photographic proof and some measurements to say that the surface has no water ice. The Americans, what we did, because this is what Americans do, is you're going to launch a projectile at it. Because just a surface landing right now doesn't do us much good. We have the ability to analyze dust in the air. So what's the best way to create icy dust? Is to hit a comet with an object with kinetic energy that's not going to bounce, but it's actually has enough kinetic energy to do some penetration and cause an explosion. And it probably did bounce back off. It didn't have enough kinetic energy to go through. So I don't have all the proof, but you know, physics tells you that it'll do an explosion, but it's going to also bounce away in its opposite and equal reaction. I think there's video of that or pictures of that. But what they found, we found, NASA found, JPL found, wasn't widely published, and everybody was surprised that in the analysis of that dust, there was hydrogen, there was oxygen, but there was no proof of water ice. What there was mostly, there were small traces again of oxygen and of hydrogen, which are wholly and very abundant in space. So these little molecules of hydrogen and oxygen, you know, they can the traces that they registered were so minimal that you could go ahead, if you were an honest scientist, that you could say that's background noise. Those levels of hydrogen and oxygen are not sufficient to indicate water present anywhere on that comet, because the traces were so minimal that they could have just been background noise. But no, I mean, everybody in NASA, everybody in JPL, all of anybody that is in academia that has to teach, talk, or study comets will tell you by voice that they're made of ice, that they contain the elements of what created the solar system 4.5 billion years ago, and that they are just magnificent, and they outgas, and then they leave a trail of dust, which is all fairyland made up nonsense, because they do none of that. Because we could never see, you know, these guys can be up to 1 kilometer, maybe 2 kilometers in width, in makeup. Again, just dust and rock, but they can be a kilometer or 2, you know, a mile. They may, but they're pretty tiny actually. What we found. So most of them don't even make up a kilometer. But we've seen them create a coma, what they call a coma, which is that bright head, and then that tail, and they've seen that, which is the outgassing and dust, they say, but they have no visual proof. So what we do have visual proof of is 7 comets, and they all have the same thing in common: no ice, no water, minimal amounts of registered H, hydrogen, and O, oxygen, but none of them combined together to be H2Os. None of that was registered. But they did register mostly dust and mostly rock in the makeup of what was the debris of the impact, which the NASA made. But vocally, ice, baby. Scientifically, dust, rock, baby. Weak gravitational force, baby. Ice, a big old chunk. Science from 100 years ago, still in the classroom today. Science from today. Why? Because I got my PhD off of that idea. I have my thesis, my master's thesis is off that idea. And I've taught all of my students that idea. I cannot be wrong on that principle. The other thing that we've been studying is the sun. So the sun, I feel, I'm taking my responsibility, is too far north in its sunset. And I am casting a shadow that is too long for where I am in the United States. So in this video, I'm not going to give you any measurements. But if you have a sunset place that you know that middle of May, the sun should be setting here, but it's setting too far north there, can you please make a note in the comment section? And those of you who are mathematically inclined and know how to do the math, can you measure your shadow at noon and do the calculations as to what your shadow should actually be? Because I feel my shadow is far too long for where it should be, where I am. So there is, and finally, I have done some measurements off of some megalithic monuments that I had previously proven in other videos and with friends of mine, but I really didn't make a big documentation. I can go through my archives and pull some of that stuff up, but that these megalithic monuments pointed north, and I could prove it with magnetic north, and everybody's like, ooh, ah. Now they don't point magnetic north anymore. They're pointing 4 to 5 degrees off magnetic north for me. So if you know an object that you know points magnetic north, points true north, because that's what it is. These megalithic objects pointed true north, but now they're not meeting, and the true north and the magnetic north actually met up, but now they're not meeting up at all. And I can't make them meet up. So these objects used to point, I don't want to say, again, that's not right, and I can't clip this out. These objects pointed magnetic north, all right? Yeah, that's correct. That's saying it correct. These objects that are megalithic for me pointed to magnetic north. They are no longer pointing magnetic north. They are 4 to 5 degrees off of magnetic north. So I just want to see if people out there can verify what I am saying, because that's when you have science and we can verify it. I can verify that a comet is not made of ice. No chance. But I can't verify independently, without your help, these observations of the sun. So I need your help in doing this. Measure your shadow and do the calculation to see if it's correct for the time of year and your location, and then measure the sunset. And if you have, we're trying to get to Stonehenge to do an actual honest to goodness real calculation with a wizard, with a Celtic wizard. There are no coincidences. People have been helping the Breadcrumb Project out intensely and immensely. But I just need to find anybody out there that has a sun solstice marker that can mark it now to where it should be or where it is. Because my mark, the sun is setting for me way far north of my solstice marker. I'll tell you that right now. It blew me away yesterday. So these are just recent observations. So the live stream is at 1 p.m. Eastern Time, and we usually go 3 to 4 to 5 hours. We've gone 5 hours. You're not going to see an upload of that because it takes YouTube a long time to process 5 hours worth of video. So the live streams are not going to be coming to you quickly unless I cut them very short. But so much science is being done, and observational science is being done, and discussions are being done that they can't last 30 minutes or an hour. They have to go on 3 or 4 to 5 minutes. That's what science takes. All right, guys. Live stream at 1 p.m. See you there, Eastern Time.